And then we got another one, which we are calling it as support vector machines. So what exactly support vector machines is doing? Imagine, so drawing a line. Yeah. So imagine drawing a line to separate two groups of candies into the best possible way. So now what exactly we are doing? For example, there is two different data points. You got green data points and you got this yellow data points. So I want to segregate I want to segregate these two things. So I'm drawing a line and I'm trying to separate. These are called as green data points and these are called as yellow data points. So we are trying to classify them. So we are calling this as, normally in lines of support vector missions terminology, hyperplane. And the data points which are helping me to identify this hyperplane, we call them as support vectors based on the theory. And this is a linear hyperplane. So there are different types of hyperplanes. You can go with a polynomial. So now you can separate two different data points with a polynomial line. You can separate two different data points with a radial line. You can go for it. So now we call it as what? Hyperplane. We are trying to separate these two different points. So with the help of what? Your hyperplane. So this is the math behind it. So mostly we are using the support vector machines. So when you want to have a very good amount of accuracy for your machine learning algorithm, and it need to have a less amount of misclassification rate, and there need to be a maximum difference from one class to the another class. So now between a cat and a dog, if you want to have a major difference, you can go with a support vector machine. So support vector are used in order to have a maximum difference between two different classes. And in order to, so means like mostly used for when you are having an imbalanced data, you can use this kind of support vector. What it is doing, imagine drawing a line to separate two groups of candies into the best possible way. You can separate it in a linear way, you can separate it with a polynomial way, you can separate it in a radial way. So we call them as kernels, or we can call them as hyperplanes. So where we can use it, when you are having an imbalanced data, and if you want to reduce the misclassification rate, support vector machines is one of the very good algorithm you can consider. And after SVM, so let's go to KNN algorithm. We have another one, which is KNN. We call it as K nearest neighbors, or we are able to say it as an algorithm which is not learning. So what exactly this is doing? So this algorithm never learns. What exactly this KNN is doing? Imagine you are trying to recommend. So now we all use YouTube. Imagine you are trying to recommend videos to a new YouTube user. For example, I'm a new YouTube user. It need to recommend videos. So now how exactly it can recommend new videos? Based on what similar users have watched and liked. So based on my background it's going to pick a similar audience. Based on that, it's going to recommend content to me. So now, so you find the three users most similar to, for example, if it is me, it is Sam. So based on their watch history and like, so user one, so watched and liked videos on Python, so AI tutorials and tech reviews. And user 2 watched and liked videos on data science, AI tutorials, and even coding challenges. And user 3 watched liked videos on AI tutorials, machine learning, tech product reviews, etc. So now out of these three users, the common kind of YouTube videos are AI tutorials are common for user 1, AI tutorials are common for user 2, and your AI tutorials are common for user 3. So now based on these three things, I'm taking this me and they are segregating into which kind of content we are recommending. We are trying to classify AI tutorials, or we are trying to recommend him AI tutorials to this particular person. So for a new user, we can say KNN. So what KNN is doing? So we are trying to classify the product based on the similarity or based on the nearest neighbor. So how exactly I can say that? So now there is a weekend. For example, now there is a Saturday coming in. So man, which type of movie he like, for example. So now so someone want to take me surprise and he want to, or for example, someone need to buy a shirt, for example. No, let's take it as a shirt. Someone want to buy a shirt to me on my birthday. So how they will be knowing? So they look at my dresses. So which colors I'm buying more, whether I'm wearing a plain shirts, or whether I'm wearing a check shirts, or whether I'm wearing a linen shirts, or whether I'm going with some trendy shirts like Gen Z kind of models, or from which brand. So based on the similarity, okay, majority of the time he is buying shirts from brand X, from brand Y, from brand Z, and majority of the shirts he is wearing are from brand X. So let's buy brand X to him. So I'm classifying what I'm liking to me or how someone want to present to me based on my similarity. Okay, this guy is watch or this guy is wearing this kind of shirts more, or they are trying to go and check with my friends. Majority of my friends are saying, man, let's go and buy him. So like this particular brand. So based on that nearest possible way, they are trying to do it. So now we are calling it as what? So now your KNN algorithm, what your KNN algorithm is doing, it is trying to make the recommendations, or it is trying to make a classification based on similarity. So it is not learning anything. Based on just a similarity, it is trying to classify one over the another. So we call it as what? KNN algorithm. Now after KNN algorithm, so we got another one, so which is called as ANN. Oh, KNN and ANN are different. We call it as neural networks. So if you see neural networks, CNNs, autoencoders, so even this one, RNNs, all this falls into your advanced algorithms, or we can say all these types falls into your deep learning. So what is deep learning? So the study of neural networks, we can say the study of artificial neural networks, we call it as deep learning. So initially the ANN started in the year 1950. It's a failure. And again, they started doing a lot of research from 2010. So which we are calling it as what? Deep learning. So the study of research or the research on deep learning started. So from 2010, the study or the research of deep learning started into the picture. Now, if you are able to see all this ChatGPT, or if you are able to see image generation and all this, if you are seeing that, it is all because of your deep learning, which is started in 1950 and again recontinued it from 2010. So let's try to read about this neural networks. What is this neural network? Now, I'm not going it so deep into this neural network. Let me just touch it. So it is more like your neurons. So what exactly is that? Imagine, so your brain has layers of neurons. So your brain is having a layers of neuron like a tiny decision makers. So now what exactly your brain is? Your brain comprises of lot of neural connections. So in order to make a movement, so each neuron need to pass the information to another neuron. As the information is passing from one neuron to the another neuron, you are able to make a hand movement. You're able to hold a cup. You're able to drink a coffee. So all these movements can be happen because of multiple connections. So that's what we are saying. Imagine your brain is having a multiple layers of neurons. Yes, we have a lots of neurons. Like each neuron is a decision maker. So each neuron is collecting the information from the dendrites. So if you see biology, you have a dendrites to a neuron. So the dendrites are collecting the information, and the neuron going to decide whether I need to send the information from this neuron to the other neuron or not. If it is sending, we are able to make an action. If it is not sending, you don't make an action. So that's what paralysis people do that. So if their hand is paralyzed, the neurons related to hand movement are dead. So the information is not passing. When the information is not passing, what happens? He is unable to make any movement. He is unable to feel anything. So that's what happens. So now each neuron is a decision maker. You can see this. So now this is an input layer. For example, so this is your input layer. So now this is a neuron. So now we can say input layer, and this is your hidden layer. This is your another hidden layer, and this is your, this is your output layer, and this is your, what is that? Your function. So the loss function, we are trying to do that. So now what exactly this point is doing? We are collecting the information input. We are sending it to this particular neuron. This neuron is deciding whether I need to send this information to this neuron or not. So it is deciding, or do I need to send this to this neuron or not, or to this neuron or not, or this to neuron or not. So it is deciding. So based on the decision, so now the information is getting filtered or fine-tuned, and we are able to get a final data at this particular output layer. From the output layer, we are trying to calculate what? The loss value, we are trying to calculate it. So now, this is in simple, we are calling it as what? A neural network. What exactly a neural network is doing? Imagine your brain has layers of neurons, like tiny decision makers. Each neuron takes some information, yes, from input layer or from the means like from the prior layer. It is trying to collect the information. It is trying to have an equation. There is an equation like y equal to, or we can say activation function of wx plus b. So that is the equation which we are having it. So now what your neural network is doing, it is trying to have this equation y equal to activation function of wx plus b. You have a different types of activations. I'm not going deep. Like what is that? Rectified linear unit, ReLU activation, sigmoid activation, tan H activation, softmax activation, soft sine activation. In this way, you have different types of activation functions. So now what is a neural network? Imagine every neural network comprises of only 3 layers. What are they? So one is your input layer, another one is your hidden layer, another one is your output layer. So now in simple, you have input nodes and you got your hidden nodes and you got your output layer. The information from this input layer passes through this hidden node 1. Information from this node passes through hidden node 2. Information from here passes through hidden node 3. From all this info, neurons going to pass through hidden node 4. And again from here, we are passing the information to the output node 1 and to the output node 2. In simple, this is a neural network. So now each neuron is deciding whether to pass the information to another neuron in the another layer or not is decided. So in this way, each information is learned and we are able to get the final information at the output. So until we minimize this loss value, these neurons keep on upgrading themselves. We call it as backpropagation. It's a very big theory. I'm not going into it. I'm not discussing. So in simple, neural network is more about, imagine your brain is having a lot of layers, tiny decision makers. Each neuron takes some information and makes a small decision. That's what we can call it as a neural network. And then we have CNNs. So CNNs are used, think of finding patterns. So CNNs are more like your, let me zoom it a bit. Yeah. So you're able to see this. So your CNN algorithms are called as convolution neural network algorithms, or we can say computer vision. So now if you are trying to build any computer vision, for example, what is computer vision? You are trying to, which color? All right, let's take this pink maybe. So computer vision. So we have computer vision. What is computer vision? So now your phones are able to automatically unlock your phone. So now your drones can recognize, your Tesla cars can recognize. So how they can see? So now your devices started seeing the things. So how they can see? So like image is nothing but a matrix of pixels. So from the image, we are trying to extract the edges of an image, maybe like a eyebrow, or maybe only the each minor parts of an image they are trying to extract. And from the edges, they are extracting the shapes. So now it's not a complete face. So it is a combination of only eye part of it, or the nose part of it, or the lips part of it. They are trying to extract what shapes. And from the shapes, they are trying to extract the overall object. So now that's the reason if you take a human can recognize, if I'm seeing a person from a very long time, just with only minor combinations of his face, I can recognize him. So even if there is a power cut based on his outer line, the shape we can say, or the edges, I can recognize him. That's the reason your CNN is learning the edges, it is learning the shapes, it is learning the object. So in order to do this, so we are using CNN algorithm. If you take the CNN algorithm, if you apply it, we call it as computer vision. You can do this CNN or computer vision with the help of OpenCV library, with the help of TensorFlow, with the help of Keras, with the help of PyTorch. With any of these libraries, you can do it. And one more thing is, like whenever you are doing this, there are layers within CNN. So we call it as convolution layer. We got max pooling layer. We got again convolution layer, and simple. In this way, we'll be having a combination of convolution layer, max pooling layer, you will be having again activation functions between convolution and max pooling. You will be having activation functions, rectify, linear unit, and then you will be having a feed forward layer. So this is called a neural network, which is a feed forward layer. So in this way, you will be having this type of layers in your CNN algorithms. I'm not going deep. So now, in order to extract it, you want a convolution metric. You need to have an activation function. You need to have a max pooling layer so that you are able to get edges. And on the edges, when you apply a conva, you get again this kind of shapes. Again, on top of the shapes, when you apply a conva, you get the object. So there is a theory behind it. So, but CNNs are used in order to perform image recognition kind of operations. And now let's get into another algorithm, so which is called your autoencoders. So autoencoders a bit an introduction to your Gen AI, a bit introduction to your Gen AI. So why your autoencoders are a bit introduction to your Gen AI? Take a CNN image. Think of compressing a big picture into a tiny, that's what we are doing. We are taking a big image. We are applying convolution, max pooling, which you saw it in CNN. You are getting a compressed image. That compressed image is again getting decompressed into a very big image. So tiny one, and then expanding it back. We call it as autoencoders. We are taking an image, reducing the size, and then we are expanding it. So now we are making an algorithm to learn this. So by learning it, what happens? So we can, instead of taking a very big image, now I can take this image. So that why? So this tiny image contains a knowledge to recreate a big image. So I can take this tiny image. So my memory is saved. My computational power is saved. I'm able to run things at a less amount of budget. So we call it as autoencoders. So which falls under a category of unsupervised learning. It is a very beginning of, so we are generating an image. So we are collecting an image and we are generating. If you take CNNs, all these algorithms we learn, we haven't generated anything. We are just saying whether it is cat or a dog, whether it is a candy or this, whether he's a diabetic or not. We have all these algorithms. From autoencoders, we are trying to generate an image. So this is a part of your generative AI. So by taking one part of the data, it is generating another part of the data. So autoencoders we cannot say, but it's a kind of a beginning. We got GANs and all that. And then we got RNNs. RNNs are called recurrent neural networks. So think of writing a story where each word depends on the previous word. Now, here, see this word. Now, the new design is awful. So in order to make a statement, the new design is awful. So now there is a connection of every word. So now based on the word the, another word is dependent. So based on new, another word is dependent. So that's what we are saying. Think of writing a story where each word depends on the previous word. Now, if you're taking H, T minus 1. So this is your output. So I don't want to go a lot of theory. So in simple, so now I'm writing a word hi, for example. So based on the word hi, the next word in your keypad is predicted. So based on the word hi, it is predicting, okay, how. So based on the word how, it is predicting based on hi, how, it is predicting another word r. So in this way, if you are able to take your keypad or if you take any language, so now each word depends on the previous word. So each word what we are able to see right now is dependent on what? Previous words. So we are calling it as what? Your RNNs, recurrent neural networks. So what recurrent neural networks going to do? They're going to take your pattern. They are able to take the previous data pattern into your particular current time slot. So now for example, previous word going to be taken as an input in your current time slot, or we can say current time event. So we call it as RNNs, or we can call it as recurrent neural networks. So now this is RNN. Again, within RNN, you have types like LSTMs and gated recurrent units. So which is RNNs, which is popular. And we got Q-learning. So now what is Q-learning? Imagine you're playing a game. So now see this. Imagine you're playing a game where you have to find the treasure, all right, in a big maze. You don't know where the treasure is. So you really don't know where the treasure is. So now you started playing the game, the treasure hunt. So, but what you can do, you can learn the best path to it by trying different paths and getting feedback. So now you don't know. For example, they gave you multiple options or multiple times to do it. So now what you can do, you don't know where exactly the treasure is. So you're going at multiple paths. So you are getting a feedback, you're learning, and you're feeling that, hey, I don't want to do it. That's what's it. So you initially have a queue table. You are choosing an action from the queue table. You're performing an action. You're measuring the reward. What is the reward? If you're able to find a treasure hunt, you're stopping it. If you're unable to find it, what exactly you're doing? Again, you're going back. Again, you're choosing another action. Again, you're performing an action. You're seeing the reward. If you got a treasure, it's a very high reward. Again, you're not getting a treasure. Again, you are going back and choosing another action. Again, performing an action. Again, getting and updating a rewards until you get a maximum record. You'll keep on choosing different types of actions. So we call it as what? Q learning. So which is a part of your reinforcement learning, which is used to create your intelligence in a self way. So now if you take ChatGPT, if someone is if it is giving you the text, if you are like it, it's going to take it as a reward. If you dislike it, it's going to feel it as a penalty. So until it's going to maximize the rewards from the people, it's going to keep on generating the right content to us. That's what your ChatGPT do. That's what your Tesla do. That's what your various gaming bots do. So which is called as what? Reinforcement learning. So in reinforcement learning, Q learning is one of an algorithm which focuses on picking up the right action. So these are some of the algorithms, AI algorithms, which are available. So we covered regression, we covered classification, we covered deep learning algorithms. In a high level, we covered reinforcement learning algorithms. I hope you got a clear idea. So now, whenever you are trying to learn ML algorithms, don't directly learn everything at the beginning. So learn the algorithms in a simple way. Once you learn it in a simple way, so now in case if you are able to understand it, so now then go to the next level. So now go back. Once you developed a lot of interest, then start going deep into the theory part. So you feel interested and you feel connected. So the goal of learning all these techniques is not to feel means like bad or not to feel frightened with this complex mathematics, and moving away from AI is not a right decision. So sticking on to it, figuring out a career in AI is one of the best possible way. So go it in a slow way, you're able to make a transition for sure. I hope you got a clear understanding about what exactly is this top AI algorithms are